we're going to be looking at logarithms. For example number one, I want you guys to just type this in on a calculator. Evaluate the logarithm using a calculator. So I want you guys, for example A, literally type in log of 327.1. Depending on your calculator, sometimes you might have to press log first and then the decimal. Sometimes you might have to press a decimal and then log. That really depends on your calculator. In my case, again, my calculator tells me log of 327.1 is, and you guys see my answer there. Usually we round it up, to either two decimal places or four decimal places. In this case, let me round it up to four decimal places. So I'm just going to say this is 2.5147. That 8 was big enough to push my 6 to a 7. And when I say big enough, it means it's 5 or more. Right? So in this case, I get 2.5147. Now, for example B, logarithm of 437,000, I literally type it in my calculator, and I'm going to get four decimal places. I'm going to say, I look at my fifth decimal, it's big enough, it's going to push my 4 over. So I'm going to say I have 5.6405. Lastly, let's take a look at example C. I type this in, and it gives me that. I see my fourth decimal place, my 2, is not big enough. I mean, my fifth decimal place, my 2 is not big enough. And once again, when I mean big enough, it's 5 or more. So I'm just going to ignore it. So I have my answer in this case is negative 1.2111. All right, so it's not too difficult. Like I said at the beginning, I want you guys to practice. Type it in on your calculator. You guys will try this, try it at home, and this should be your answers. Now, when is logarithm used? We use a logarithm in chemistry. We use the pH. It's a measure of the acidity, of a solution. Water, for example, has a pH 7. In general, acids have a pH number less than 7, and alkaline solutions have a pH values greater than 7. When you guys go and get your water, if you guys buy it at the machines, well, you just buy it there. But if you guys go to a place where they wash your bottles and they refill with water, there's some alkaline water as well. And you can even talk to them, what's the pH level of my water? And they will tell you. There's a number that they will give you. The more acid is 1, the more alkaline is 14. Neutral, like in the water, it should be 7. Now, the pH of a solution is defined by a formula. We just have this. And word H, 3O plus is the hydrogen ion concentration in moles per liter. Basically, that's the number that we have. So let's take a look at this. I know it looks like a big problem because there's a lot of reading, but it's not too bad. Wetlands are classified either as bogs, fens, or marshes, and swamps on the basis of the pH values. A pH value that is in between 6.0 and 7.5 indicates that the wetland is a rich fen. When the pH is between 4.0 and 6.0, it is a poor fen. And if the pH falls to 3.0 or less, we're going to call this wetland a bog. The sample water from a wetland, so we're trying this out. The sample water from a wetland is 6.3 times 10 to the negative 3. So how will this wetland be classified? Let's remember our formula. I gave you guys a formula, so let's remember the formula. It's negative. The pH is negative log of whatever we have. So in this case, I'm just going to write negative. My pH level is going to be negative log of 6.3 times 10 to the negative 3. Now, remember we learned how to expand. In multiplication, we expand it as an addition. So I'm going to say my pH value is going to be a negative I'm keeping that negative there. See that? But now I have a log and a multiplication. So I'm just going to expand this as log of 6.3 plus, because it was time, times log of 10 to the negative. Now, I said before that our base, when we don't have a number, the base is 10. But we learn a rule that when this to repeat, when that repeats, log base 10 of 10 to the negative 3. So remember, we learned that rule. So let's see what I have. I have negative of log of 6.3 plus a negative. Remember, we learned that rule. Now, if you guys say, well, log 6.3 minus 3 or plus a negative 3, it's the same thing. Now, let me get on a calculator. I typed in log of 6.3 minus 3. Basically, I just typed this log of 6.3 minus 3, and I have that decimal, negative 2.2. Now, because of this negative on the front and this negative on my logs, I'm gonna say my pH, right? Negative of a negative becomes positive. My pH is about 2.2007, which is less than 3, right? Remember how we had that if the pH falls to 3.0 or less, a wetland is considered a bog. So in this case, my I'm just gonna say the wetland is a bog. Right? My pH was less than 3. Now you guys try these. There's your formula. Your pH happens to be 2.9, which is less than 3. So your wetland is also a bog. Those that are working in the oil fields, they use the pH level a lot. So for those of you that are working in the oil fields, you guys are like, oh, pH, I'm familiar with this. And yes, they use this measure, the pH value a lot. Now let's find the hydrogen for the ion concentration of drinking water with a pH 6.5. Okay, what do I mean with this? Let's talk about our formula. Now I said the pH is 6.5. According to the formula, I'm just going to write 6.5 is equal to the negative log. Now, my value in the inside, my ion concentration of this drinking water, I'm just going to call it X. Now, I don't want to deal with a negative log because my calculator, I just have a positive log. So let me move everything from the left to the right and everything from the right to the left. Don't forget to switch your signs. So then I have that log of X is equal to negative 6.5. That means that my base is 10, right? We learned how to write this in exponential form. Remember how I used to talk to you guys? Write this in exponential form. Then I have this as 10 to the negative 6.5 is equal to X, right? We learned how to write this in exponential form. Now let's find out what's 10 to the negative 6.5. I type this on my calculator and it tells me 3.1622, a big number, but there is an E at the end, E to the negative 7. When I have that, when I have that little E, that means it gave it to me in scientific notation. I'm just going to call this 3.2 times 10 to the negative 7. Right, my 3.2, I ran it 1 decimal place. You guys can see 3.2. But my little e to the e negative 7 at the end, it just told me I have it in scientific notation. 3.2 times 10 to the negative 7. Now you guys can try this at home. Don't forget your formula, and those are your answers. Now we're going to talk about an e. I just said right now that log is base 10 because that's how we write our numbers, scientific notations. When we talk about how can I write my number, like I said, our number system is 10. I won't get much into it unless you guys want to. We can talk about it personally. But our base is 10. Now, Euler, that mathematician back in 1748, he found the number e. The number e is about 2.7. Now, for this one, we don't use a log. We're going to use a natural log. Now, natural log is when we have the base e. So we're going to rate this. And natural log, we call it ln. That's how we pronounce this, ln. So if you see an e, make sure you use ln. If you don't see an e, make sure you use log. So let's actually use this on a calculator. Evaluate each logarithm to 4 decimal places using a calculator. So I'm just going to type this in. ln of 0.5841. It gave me, I see my 4 decimal places. My fifth number is big enough. So I'm going to push my 6 over. So I have negative 0.5377. Just want you guys to practice how to type this in. Now, ln of 0.9215, I have to do 4 decimal places, but I do take a look at my fifth decimal. It is big enough, so it pushes the 7 to an 8. So I have negative 0.0818. What about ln of 192.7? That gives me, I see my fifth decimal place, my 3 is not big enough, so I ignore it. So I'm just going to call this 5.2611. Except I just want you guys to practice how to type this on a calculator. So you guys try this at home, and that's what you guys should be getting. Now let's take a look. The altitude in meters that correspond to an atmospheric pressure of x millibars is given by the natural logarithm function defined by f of x is equal to 51,600 minus 7,457 times ln of x. I know it sounds like mumbo jumbo, but this is just a formula. That's all it says. Use this function to find the altitude when the atmospheric pressure is 400 millibars. Round to the nearest hundred. Nearest hundred. Okay, so all I'm asking you guys here to do is, what's f of 400? So f of 400 is 51,600 minus 7,457 times ln of 400. That's really what I'm asking you guys to do. I'm literally going to type this on my calculator. 51,600 minus 7,457 times ln of 400. Notice how I did press the times. So I have to round this to the nearest hundred. That's my hundredths. My number after the 9 is too little. Remember when I say too little is 4 or less? So I'm just going to call this 6,900.